Welcome to yet another lecture of trigonometry on application of trigonometry, that is height and distance. Today we will solve one problem, that is the ninth problem in our series. Okay, so in this problem we are not dealing with the elevation angle or with the depression angle. It is something like different but related to elevation. So I'll try to explain you the problem's initial. Now what happens? Now suppose this is your ground level, and on the ground level if you have any tall object, now if there is a sun here, so the sun rays will come and hit this object. Then the shadow of the object will be on the ground. The sun ray which is coming from here like this will hit somewhere here. So this object will show the shadow which is shown in the black color. Now suppose if the position of the sun changes, I'll show the position change with some other color. Okay. So now the sun is coming in this position. So our sun is here, and now this shadow will go somewhat here like this, or sorry, it is going, I'll take the eraser. Okay. So this will come and hit like this. So now the shadow of the object will be shorter compared to the previous position. Now depending upon how the sun is moving, whether the sun is going downwards or it is coming upwards, the length of the shadow will change. So this is a situation which you will be facing in the problem. So try to remember this so that when we do the problem, you won't face any difficulty. I will erase these things. Okay, so let's begin with the problem. Find the height of the pole standing on the level ground whose shadow is found to be 45 meters longer. This word is very important. It is 45 meters longer. This is there. When sun's altitude is 30 degrees, when it was 60 degrees. So now these are the three things underlined where you have to focus, try to understand the language and accordingly draw the figure. Okay, so first you will have a solution. We are moving now a ground level. On the ground level you will be having a pole, because here the object given to us is pole C on the question. So definitely this pole will have a 90 degrees angle with the ground. Now the position of the sun, the first position is there, and the angle which we will take is of 60 degrees. Okay. So this is a position. So when the sun is at this position, the shadow of the object AB will be BC with angle 60 degrees as given here. Now let us move to the second position of the sun. The sun will go a bit down now, and then the rays will be there. So it is CD. Now the shadow of the pole is from B to C when the sun's position is here. Fine. Now try to understand the language which is used. Shadow is found to be 45 meters longer. So this shadow was 45 meters longer. So whatever, when we go for this BC, compared to this BC, when the angle becomes 30 of the sun, the shadow's length is increased by 45 meters. That is what the problem is trying to say. Shadow is found to be 45 meters longer when the sun's altitude is 30 degrees. So when it is 30 degrees, 45 meters, the length of the shadow increases compared to the original one when the angle was 60 degrees. Fine. So if this is clear, we will go for the solution. So here we will now consider BC as x. So let BC be x. So this green line, that is BD, now will be 45 plus x. So we will take down here, therefore BD or DB, whatever it is, 45 plus x. Now we have two right angle triangle, that is triangle ABC, the first right angle triangle, and the another right angle triangle ABD. In both of them we have the acute angle. In one of them is 60 degrees acute angle and the other is 30 degrees. So let's go for the solution. So it is in step 1, we are taking triangle ABC, that is a smaller triangle in which angle C is 60 degrees. Now we have to select the ratio. So the triangle which we have taken is a right angle triangle. In that, for the selection of ratio with respect to angle C, we have AB and BC given to us. AB is the opposite side and BC is the adjacent side. Now why we are taking AB? Again try to concentrate here. Our AB, it is not given, and BC we have to find out. Both the related side, which I am trying to tell you, the values are not given. But if you try to focus on the another triangle, that is A, B and D, that triangle also contains this AB side. So this AB is common to both the right angle triangle. Therefore we take this AB, which is the opposite side of angle C, and BC, which we have taken x, which we have to find out. Okay. So, and then in the same way, BD can be connected, which is 45 plus x. So in triangle ABC now we will try to select the ratio. So for your angle C, which is 60 degrees and acute angle, our AB is the opposite side and BC is the adjacent side. So definitely in relation to any acute angle, if you are handling opposite side and adjacent side, the ratio is the tan ratio, which includes the opposite side and adjacent side. Fine. So your ratio which you have selected is the tan ratio. So we will write here tan C is equal to opposite upon hypotenuse, that is AB upon BC. Then just substitute the value of C, which is 60 degrees, and another BC which we are interested in finding out is as x. Okay, so BC is substituted for x because we have considered here right in the beginning of the solution. Now from the standard trigonometric table chart, just substitute the value of tan 60, which is √3, rest everything will be kept as it is. In the next step, cross this x to the left hand side, so you will get 3√x is equal to AB. Okay, now go for the second triangle. In the second triangle, again the same way, the triangle is ABD, in which angle B is 90 and angle D is 30 degrees, that is the acute angle. Now, in respect to angle D, which is 30 degrees, we have AB and BD. One of them is the opposite side and BD is the adjacent side. Similar to the first part, opposite and adjacent, then the ratio is tan ratio. Here we are going to handle the acute angle D, therefore it is tan D equals opposite AB upon the adjacent side, DB or BD, whatever it is there, you write, it is okay. Now here the value of angle D is 30 degrees and this value, that is DB, is 45 plus x. I'll just indicate it with the pen. So this is a value coming here for dB. Okay. So on substituting the values, we get tan 30. The value of angle D is 30. Then value of dB, which is connected, shown on the screen, is 45 plus x. Now the value of tan 30 from the standard trigonometric table chart is 1 upon root 3. So it is 1 upon root 3 equals AB upon 45 plus x as it is. Now in the next step, we will cross the 45 plus x to the left hand side, giving you 45 plus x upon root 3 is equal to AB. Okay. So now we will check out that in step 1 and step 2 we get the value of AB. So this is the value of AB here, which is 3 root x, and the value of AB in the second step is 45 plus x upon 3 root x. So compare step 1 and step 2. So here you will get x root 3 is equal to 45 plus x upon root 3. Now here onwards there is a simple calculation. Just transfer this root 3 from the denominator to the left hand side. So it will become root 9 x is equal to 45 plus x. Root 9 is 3, therefore you will get 3x equals 45 plus x. Now transfer this x to the left hand side, so it will become 3x minus x is equal to 45. Then mere subtraction will give you 2x equals 45. Then taking the 2 to the right hand side in division, it will become x is equal to 45 by 2, and then the simple division will give you 22.5 meters. So this is the value of x. Now put the value of x, this value of x, you can substitute in A or this AB or another AB, which is from step 1 or step 2. It is advisable to take the value of AB of the first step, because here we have just root 3x. So put x is equal to 22.5 in step 1, that is, you will have here step 1, that is root 3x is equal to AB, which is taken from this position. Okay, so here we have brought that value of AB is equal to 3 root x. Now the value of x which we have got in the previous step is 22.5. Just substitute there. It will become root 3 into 22.5 is equal to AB. Now try to substitute the value of root 3 also, which is a standard value 1.73. So that is 1.73 into 22 by 22.7 is equal to AB. Simple multiplication, you will get 38.93 is equal to AB. Okay. So with this, we got the height of the pole in which we have been directed in the problem, that is, find the height of the pole standing on level ground whose shadow is found to be 45 meters longer. So this was your pole height. Okay. So the problem has been completed. So AB is equal to this part. So thank you students for watching the video. Oh, sorry, the answer part is remaining here. The width of the river, this is not connected to this problem, it is from somewhere else. And the height of the pole, this you have to take it, keep it here. Yeah, so this is not there, just rub it out. So this was some other problem. Okay. So thank you for watching your life with Khandekar Sir. If you like the video, just press the like button. Subscribe to my channel, Kit Classroom. Thank you very much. Good night.